have a cool demo, which is going to show you the end-to-end pipeline running a small piece of app, which should actually satisfy any other things that you're trying to do in your organization, right? So we'll walk to a demo, and I'll tell you why we talk about microservices in a few minutes. So the agenda is, what are microservices? It's everybody talks about it, although it was I think it was launched in the early 2012 and 13 when Azure Wave started picking up. We'll talk about that, when, why, and where they are used, deployment techniques, and how can developers work with microservices and containers, and the tools required to do that. Brian has a demo, and then I can show you the piece, how it interacts within Kubernetes. We're going to stick with the cloud today, Azure Cloud, and show AKS. We're going to use the service. We're not going to be so crazy and go into the Kubernetes kernel, but the same concept can be done on-premise as well. And we're going to touch on orchestration. It's a very important topic, but this should have evolved into a presentation on its own, but we didn't get to do it this time. But again, next time when this continues, we'll evolve this topic to Kubernetes and all that good stuff. A little bit about NEUDESIC. For those of you who haven't heard about us, Brian and I work for NEUDESIC. Some of the stuff that we're proud of, we have a solution areas covering digital and app innovation. That's where Brian and I work in a team. We have a very big data practice. We're proud of that, and we have several awards. One of the reasons was for the data and AI. We have 12 competencies, and recently, if you haven't heard the news, we just got acquired by IBM. We have a very good synergy between our apps team and data team, and we have several accelerators that work well together. But this is for you guys later to poke into this. About the speakers, I'm going to first tell about myself, and then I'm going to switch over to Brian. So I am a technical architect. I have been at NEUDESIC for 10 years now, at least, and I have about 14 years of experience doing Microsoft technologies. So I've done everything starting from SharePoint 2003. I've been with the Azure Wave since the digital transformation started in 2012. My recent experience was we have been doing a lot of microservices, and we are also doing a lot of monolith applications for our clients based on what technology fits in. But because of coming from various backgrounds, I'm able to understand why you can use microservices versus not, and I'm interested in making my clients understand the needs for it. Brian, go for it, buddy.
Yeah, so I'm a solution architect at NEUDESIC. I've been there for about 4.5 years, which is a long time. So Poornima being there for 10 years is definitely an achievement. I'm a Microsoft MVP, and this is a little outdated, the description. I used to be an ALM Ranger, but that group no longer exists. I speak at a lot of events, but I'm also the organizer of Philly Azure and the Tech Bash conference up in the Poconos at the Kalahari. Each year, we had to cancel the last 2 years, or maybe 3, because of COVID. But this year, we see nothing that's going to stop us. So it's going to probably be in November. I don't believe we released dates yet, but keep an eye out for that, because it's a phenomenal conference at a really great resort that has a wonderful water park, and you can bring the kids. So that's something definitely to take a look at. So that's about it for me.
Definitely looking forward to that, Brian, because I remember talking to you about it 3 years ago, and then COVID came in.
Yeah.
Cool. Okay, so let's dive into our topic for today, microservices. What I know about microservices, right, and how I understand microservices. And it's going to be a little bit of talk for the first 20 minutes. So please feel free to interject so we can make this interactive. One thing I see when clients come to us and say, oh, I need my team. We are consultants, so obviously they bring us for some expertise. And they say, oh, we need to do this in microservice. And the first question we ask is, why do you want to do microservice? They tend to focus on the technology more than the outcome for it. And I have had several clients build microservices to realize that they could have just did this capability easier in a monolith application, right? So if you don't have a desired outcome, And if you're just using it for the sake of technology, because microservice is cool, you have several apps, you can deploy it on the cloud, and you can boast that your web app is running on a microservice instead of monolith, right? Then it's not for you. It's just an architectural pattern. And when I say monolith, it's a traditional app. It's a full stack. When you advertise for a full stack engineer, you somebody who understands web, the middle tier, and the database. And you put that in a single process, you spin it up, it runs. And can you use cloud for it? Totally you can. Can you use DevOps for it? Yes, you can. It's a distributed architecture. It's very good, plain vanilla. All of us know how to do it. So why microservice, right? It's an architectural pattern, and it came into practice when cloud was in practice as well. But all of these bigger companies had several processes running together, and they were not able to scale up. For example, Netflix. Netflix has come a long way, and I'm sure you guys have all understood about how these guys run data, especially when you were watching the thing, that Kevin Spacey thing, which is no longer the lost. Somebody help me here. So that sitcom, and you know how that sitcom came into place, right? They had all these huge amount of data, and when they were trying to manipulate this data, they understood when you put Kevin Spacey, when you put this particular director and everybody in a project, and you fire it, it's going to be a hit. House of Cards, I got it. So that's how Netflix came into being. But when Netflix tried to scale their application, it started failing. Right. And in my screen on my left, you can see a web app that I talked about. You have a database. Maybe you imagine this blue is like your web application, and then you have a database. When you scale this, you may not have several users hitting your database today, but you might want to scale 2 times like a cookie cutter. So you scale it multiple times, and that's all you get. But if it was a microservice, let's say the movie got released, and the first week everybody is going to watch it crazy, so we are releasing on Netflix. You can independently deploy the client user interface, and you can mix and match these services. So they are flexible, and different services can run on different machines and with zero downtime. So that's the reason why microservices became popular. But if there's not a good reason, for example, if you don't have a bigger teams working on a technology, let's say if you do not have multiple services, if you don't need that zero downtime, it's a monster that you wouldn't want to work with, right? And you can achieve the same qualities of clouds. You can achieve the same quality of pipeline DevOps deployment using a monolith service as is. Now, one good thing about microservices, everything interacts. So I'm going to go to the next slide, but in this, we're going to refer to this image after in the next slide as well. But it helps you break down the services smaller. So if you had a giant monolith, you're breaking them into different services, which means you're bringing different teams. Now, when you bring different teams, make sure they're working towards the same objective. Like, for example, on the right side, you have a login service. The login service basically has an authentication, you're logging in, and then the end result is you're signing into a page. That's the functionality, and the functionality should not be broken into different departments. So you should have the full stack within the same team. You're all working out of the same project or repo, and then you're able to be deploy it as a single service. So in my opinion, my experience, it shouldn't be the default option. Think of it more like a service-oriented architecture. So try with one of the modules that you have today, and let's say you want to scale it out a little bit. So split it up based on your domain capability in your code base. Split it and just move it a little bit and see how it works for you, and then you can go for microservices. So when and where, like I alluded in my previous slide, focus on the outcome, not because of the technology, not because of you want to use the microservice, but on the activity. So let's say I'm a healthcare company. What are those outcomes that you typically need, right? Zero downtime, independent deployability. For example, SaaS-based businesses, you have a client, let's say you're an insurance company and you have an auto insurance, you have home insurance, and you can't club them together. Let's say you have them all in one big monolith. What happens if your auto insurance service is down? you're also going to take out your home insurance. But if they were all separate services, and if they're all connecting through API, which is on the green, because all these microservices should always talk through an API, and there's a reason for that. If that's your goal, if you want zero downtime, you can miss your clients, even if you, like, if, for example, Amazon, right? You don't want to see your shopping cart. I keep clicking buttons on my thing. And sometimes when I'm on different browsers, we talked about this, when you're different sign-in, it's not going to work. And we are immediately frustrated. We can have frustration. We are all used to clicking images quickly. So if you're in that sort of business and you want zero downtime, independently deploy these services without having a problem in losing a customer base, and it's for you. But what's the negative that you're getting for it is the consistency. Sometimes even the most robust applications, you can see something missing. For example, I don't know how many of you noticed, but if you are shopping on Thanksgiving, you can see the recommendation feature in Amazon may not work. Have you ever thought about it? Why? Because it's just an independent service. Even the best robust companies implementing microservices do not have some functionalities working. But that's not going to affect that you're going to buy it and pay for it. That's still going to work, but then you may not be able to see the recommendation feature. So again, the scalability of microservices, you don't have to scale the recommendation service as much as you do scale the shopping cart where people actually pay for that resource that you're buying. I'm going to stop here for a second and see if anybody has questions on what we discussed so far, and at least your experiences in developing microservices or hearing about this concept.
I have one question with microservices.
Sure.
So I haven't developed any microservices, but I'm fascinated by them, and I've done a lot of research on them. And one concept eludes me because I've seen it done two different ways. When it comes to the UI, right? You have the teams that one of the things about microservices I understand is that you have the team, and they support like one microservice. And this one class I saw, they basically had a demo where like the team supported the whole entire microservice. Even like they would have like a it was like an Amazon site where they like an order application where they would support the order page and the API, the whole back end. And then another class I took, recurring microservice, basically said, well, you have an API, different API teams, and then maybe you have a separate team that just supports the UI and they develop the UI. So I'm curious about like how, and I'm guessing the answer, it depends on what your needs are. But what if your experience when it comes to microservices in regards to UI?
Very interesting question. Yeah. So I'm actually working on a project right now, which just the front end microservice. It's called micro front end. Okay. And we have different teams only developing components on the UI, and we have nothing to do with the backend. Okay. So we develop all these components independently of each other, only because it's a very huge application. And if you use React or Angular, it's very easy to deploy them as components, and you can use several technologies. That's one idea. So I can take advantage of what Angular has to offer in one of the components, whereas React, which is basically a JavaScript, as a loaded JavaScript library, you don't have to worry about setting it up. It's very very small, thin footprint. Let's say that, and that's the reason why I would think you would break a front end to multiple microservices. But usually, I think it should focus on a business objective. So if you're not a big PwC or one of the bigger companies that need such a huge micro front end, I would say if you can buy a pizza for your employee, for the team that you're working with, and you can't share the pizza among themselves, then it's too big of a team. You have to break it down at that point. I don't know if that answered your question, though. I'm trying to get there. So another thing is these front ends that they're talking to each other are connecting in the back end using microservices too. And they are totally different, and they're using different platforms, especially in a company which uses different technologies. In the use case you mentioned some microservices are full stack, some are just front end. Do you know the type of technologies? Do they need containerization? Maybe that becomes an aspect of it. The versioning, like for example, some teams cannot upgrade easily because when you're upgrading one service on the front end, you might also have to upgrade the back end, right? And sometimes you don't have to. And when you don't have to, you just split them up. And again, I'm not a fan of splitting up business objectives. I think I like whatever has worked for the bigger companies, like you keep one service as a whole. And data, there's one more point there, isolation of data and processing around data, right? The data has to be kept separately, independently for every of your microservice. And you should be able to talk between these two services using the API layer. You never touch the data. So don't share data between your different services because it's going to cause conflict. Let's say that you are having a credit card application, you're crediting, so let's say you're paying for something, but then your account is locked, but it's not able to take the money out of your bank. So that transaction is invalid. So somebody has to do the rollback. And unless you have that modularity defined between domains, I would not be able to split it up for smaller applications. Did that answer your question? Or maybe you can clarify a little bit more?
Yeah, no. I mean, again, I think you more or less did, like more or less, like basically, I think it's, and I kind of knew the answer basically that it
Right.
really depends on, it depends, which is like the answer for so many questions when it comes to software development, right? But I just wondering if I was kind of more like, no, this is the way you definitely do it. And again, it sounds like it really depends on the situation that, what your business needs are and the size of your teams and just everything else that comes into play, right?
Most oftenly, you stay away from it. So if you're pushing to do a microservice, we just developed a function for another client. We developed, and serverless is different from microservices. So there's a lot of confusion in the industry. We talk about serverless a lot, Azure Functions. You're able to provide hooks for them and it keeps running. That's totally different from microservice. So microservice is a component that can exist without having to talk to another, unless it's a networking of communicating protocols. So you talk between each other using REST API mechanism, or it could be a service bus or whatever. Similar to a service-oriented architecture, like the enterprise service bus that was very popular 5 years ago, right? Where you have to bring all these data guys trying to interpret data between different formats. Microservice, very small part of it, and it does it really well. Follow Sam Newman. He has written 2 books on it, and I follow that guy, and he's pretty good at telling why you should and why you shouldn't. And if you were using the thought process when you're developing your application, basically you don't want microservice. Anyway, moving on. So isolation of data, we talked about that. If you are in a healthcare and you want to protect your data and you don't want your other service to see it, you just create an interface out of it. We are all programmers. We know how to protect our data behind interfaces. And then when you have two communicating when you have two communicating APIs, you make sure the networking happens between them. Another reason why Brian's demo is very important is you can't do microservices without DevOps culture in place, because you need to enable a high degree of organizational autonomy. Let's say you have bigger teams and we're all deploying features every day and it has to go through quick. You can't wait on another team to make a change to the service. You deploy a service as if it existed, or if it doesn't exist, there should be a rollback mechanism in your code to revert it. And there's a lot of autonomy in your company and you're able to do that. Microservice for you. Limit the failure radius. Again, we talked about that feature, recommendation feature. When that goes down, your whole Amazon experience does not go down, right? So see what's important for you. See if you're in a SaaS business, you can lose your customers and there cannot be downtime. You can scale up. In the previous figure, when we talked about scaling up, you're going to create cookie cutter copies of application. Maybe you don't have to spend all that money. You just need some services that need to be running 100% of the time. You buy hardware for it and compute and storage in Azure, right? Okay, so we talked about whys. One thing I want to touch about is the partial deployment for microservices, right? Let's say you have a big monolith application and you refer a lot of third-party libraries, because nowadays everything has a library in it. And it's very hard to actually publish your code or compile your code without touching other pieces of the code. It just gets broken. If you have worked on a giant C# application, you would know that. But let's say if it's being split into different web methods or web services. So you can have a separate version of Java in one application. You can independently publish and compile the DLL without having to affect another app that's talking to it. One thing I want to show a real world example. When you go to Netflix or Comcast or whoever, right, and you're getting a subscription, they always send you a box. You're renewing it or going there for a query or enhancing it. Have you ever wondered why? Because they have different versions of their software running, right? And every time you go, they're always upgrading the service, although they have to keep another version of service for their older customers who have the older equipment. So every time I go there, they give me a free equipment. Oh, we have the latest technology. So you have to make sure the deployment techniques are in place, like canary deployments. You have to have a subset of APIs that work for new customers. At the same time, you're not ditching your older customers who don't get to go to a Comcast store to get that interface. So those are the places where I see microservices add more value. Also multiple platforms, right? And able to upgrade independently and impact and minimizing the radius of failure and all that. But let's say you want to do microservices, right? So what do you want to keep with all these gotchas? Let's say you've picked microservices. What do you need? You need to provision new machines rapidly because if you don't do that, if your service is going to fail, if you don't need that capability, you're not into microservice. But if you're into microservice because I need that capability, make sure you have the ability to create VMs or maybe PaaS environments immediately as you scale up. You have to have monitoring in place too. And we'll talk about that a little bit later on the call. But when a service goes down, you have to be alerted. Oh, my service is down. So I need to make sure the health check is in place. I'm able to report or throw alerts in place. Without this, do not develop a microservice. You have to deploy a service very rapidly. So that's where the pipeline stuff that we're going to show in a demo in a few minutes is going to solve that problem, because rapid deployment strategy, then you need to change the culture, right? It's very hard to get a developer to check out a master brand and check in code. And these are technical people you're talking about. DevOps is not just technology. We need to work with operations people, which means they have to change the old way of installing their, making sure the environment has all the tools you needed. Because let's say you're providing a Kubernetes container or some Linux container on the cloud, you still need to install some of the components that's required for your code, which has been developed in a developer's machine, can execute there. So there's a lot of change in culture. There's too many deployment strategies. And in this call, we're just scratching the surface, right? And there's many more things we can talk about. But if you see the technique on my screen, we are going to show you a small CS project that I compiled on my machine, and then we push it to the cloud in DevOps. And Brian has set up the architecture end-to-end. So it's in a Git repo, and we're going to use a CI/CD pipeline. We're going to publish an artifact. In this case, our artifact is an image. So we built it as a container, and containerization is a huge topic when it comes to microservices, right? And that's for another day. But we push the container, which is an independent deployable code base that you can download from the internet, from Docker or from Azure Container Registry. And then we are pushing it through a pipeline to a Kubernetes cluster. Kubernetes is nothing but an orchestration engine. Let's say we are just showing you a simple Docker image, right? If you had multiple Docker images, let's say you have a web, I think one of my buddy, Brian, just gave another presentation for multi-container app services. So if you had multiple Docker images, you need something like Kubernetes. And Kubernetes is moving away from Docker. This is an old slide, but we'll update that soon. So Brian, I think I'm done, and go for your demo, and then we can.
Yeah, why don't you, so we have an AKS running in Azure and container registry. So what we're going to do, I'm going to show you the end-to-end of how a developer would work and how it could get deployed. So I'm going to be making a code change. Poornima, I don't know if this is the time to show what's in the what's in AKS
Oh, I can
now,
show it. Yeah, I can show it.
while you're
Brian.
sharing,
Hold on, let me
or-
share again.
Okay.
Sure.
and then you can share it after you do the
Absolutely.
deploy.
Okay, can everybody see my screen? So here is my Visual Studio Code, and I'm a developer, and I have the project. This is a very basic web app. View my Solution Explorer. Okay, so you have everything. We have a Docker file, and that's another separate topic, how to create Docker files. Docker file is like an instruction to create an image locally. Okay, that's about it. And then we have some microservices YAML. Brian is going to touch about it. And we have a simple web service which provides temperature. Now, we push that code. If we don't push that code, if I'm running this locally, you just deploy it in your IIS Express, and that's your output. It's a service. It provides temperature. It says it's probably having the old code, but Brian updated that after the fact, so it's going to show freezing, right? So we deployed this container inside Kubernetes. Let me exit this. I installed Kubernetes. It's a kubectl is a set of instructions, or it's an exe tool, right? It's a Unix shell that lets you talk to Kubernetes inside Azure. So I installed this. I have a bunch of commands that I use to set it up, which I show in my cheat sheet. So you have to make sure you talk to Azure, log in. The container is in the image that Brian is going to push is in a container registry, and then my code is in Visual Studio. So we make sure we get the connection between the Kubernetes cluster and your container registry. I did all that. And after I did that, all I have to do is kubectl get pods. You see when it's running, and I go into this pod, and these are all Linux commands, right? And then I do a curl. So whatever I'm doing locally, connection refused. It's the same thing. It's been running for 166 minutes. It should, oh, I know why, because the port, I have it port forwarded to 5000. So I can have 59134 inside the container. So container, let me just do this, type it in. So it's running on port 5000 inside my container, and that's my launch URL. You can see that's the code without any update. It says freezing, and you can see it's running inside the kubectl, which means you haven't talked to the container inside. So Brian, do you want to take it over? And once you made the change, we can show how this data changes. He's going to make some changes to the code through the pipeline, and he's going to refresh the container, which means the age of the container would be like maybe a second. It was created a second ago, and then we'll show how the code reflects in the pipeline.
All right, cool, thanks. So let's let me share. Make sure everybody can see it before I start. Is this viewable at this point?
Yes.
Yes.
Yeah,
All right.
I can see it, Brian.
Awesome. Okay. So what I'm going to do is show the end-to-end of a flow from the developer all the way through to deploying to an AKS cluster, and then Poornima will show the change that we made, that I make, and then show it running within AKS. So I'm in Visual Studio Code, and we know that you need to have a branching strategy. You work out of your feature branch, you do PRs to your development branch or whatever your strategy is, and that's how you get things promoted to your different environments. We're not getting that deep. We're doing everything in master, no branch protection rules or anything. So I just wanted to show you a little bit more detail about this project. It's just a regular .NET project, and a couple things that we have here we have a Docker file, and we have a deployment.yaml file. And what these two things are going to do is, first of all, create the artifact or the image. And then it's also going to show the deployment.yaml is going to show how AKS should be configured in order to point to that image and run. So let's go take a look at this Docker file quickly. So it's very simple. We have an ASP.NET image, and then we have another image underneath that is going to be where we do a build. So what this is going to do when it's run is it's going to build our application, get the DLLs compiled, and then it's going to copy it over into our base image, and this base image is the thing that's going to get deployed to Kubernetes, and it's going to run that way. So during the build phase, we're going to be compiling and creating this image, and then we're going to be publishing the image to the container registry. So we could think of pipelines with .NET applications, not microservices, just regular Java, Python, whatever, where a build will actually compile, package, and put it in a drop folder as an artifact. And then you have later stages, dev, test, QA through prod, that's going to deploy that image or that artifact to all the different environments, the same version of code. We'll go from environment to environment. So this is a little bit different, but it's the same concept. Our image is now the artifact that's going to be, and our drop folder is in the container registry. And we're going to deploy that version of our image to the different environments, dev, test, QA, prod, whatever you have set up. So it parallels what a developer who is just doing non-microservices development would do, but just using a different pattern as far as ACR is now our drop. That's where our drop is and our artifact, and Kubernetes is what we are deploying to. So when we look at this deployment.yaml file, this is an incredibly simple one. It can get incredibly complicated because you can get networking configurations in here. You can get secrets in here as far as key vault integration and all those type of things. But what this is doing is it's setting up our specifications for what this pod is going to look like. And we can see here we have one replica. It's going to be named LHV pod, and we are going to have a container that we're pointing to, which is this. This is our URL to the to ACR. Now, all of this stuff, this tag and everything, this will be overridden when we do the deploy. So it's going to point to our latest configuration or artifact that's going to be in ACR when we do a deployment. We also have a YAML file for our pipeline. And if we take a look at this, I will go over now to a browser so you could show this in a little bit. No, we could do it here. All right, yeah, I thought I was using a template here, but I'm not. All right, so this is our YAML, and this is what our multi-stage pipeline looks like. We have variables here as far as what our image repository is in ACR, our container registry URL, our Docker file pass, and our service connection within Azure DevOps. So we're going to be using Azure pipelines for this. And we need a service connection that's going to point to ACR so that we can do our publish there. As far as our stages are concerned, as far as our deployment stages, we have dev here, but we could also have dev and other environments that are being deployed to based on approvals or whatever you have for the environment. But you can see here we have an environment name, and this is just an Azure Pipelines environment. We have a variable group, and this variable group is going to have specific information for what the configuration is for AKS, for example. You know how we have a function app or something, app service, and we need to have configurations that are different from environment to environment. We usually use a variable group in order to get the values for that when we do our deployments. And then we have our AKS service connection. So it's the same thing as the service connection for the Docker registry, we need to have a connection to our AKS too within Azure Pipelines. So what the build is doing, this is the build stage. The build stage is doing NuGet restore. It's very simple. And then you can notice we're not doing a build here. We could do a build because if we want to run unit tests and all those types of things, we could probably do that here, which I would recommend doing before even getting to this Docker stage, which is really going to be building our image and publishing it. So for simplicity, we don't have any of that stuff here. So pretend that we did do that and then the unit test passed. So now we get to this task. And what this task is going to do, it's going to build our image from using the Docker file. Within that building of our image, it's going to be doing a compilation within one of our sub images within the Docker file, getting the DLL, and then those DLLs are going to be copied over to our base, and then it's going to get published to ACR. So this is all of the information that we need for that in order to do it. And the tag's important because that's basically going to be the name of our container. And then we're going to be copying our files because we're going to need that deployment.yaml in order to do the AKS. So we have two drop folders here when you think about it. We have the ACR holding our image, and then we're going to have within the Azure pipeline run, we're going to have an artifact that just has our deployment.yaml in there. So we can use that for our deployments. So coming down to here, this is our deployment stage to dev. And you can see that we have, we're using a deployment job here, and we're specifying our environment to deploy to. And we also have our variable group that's for this stage. But when we get down to here, these are the two tasks that really are doing all the work. They're Kubernetes manifest tasks. And what this first one's doing is it's creating a secret based on a image secret that I have in the variable group. So it uses this, this secret that I have in the variable group, and it's hidden, but it has a bunch of random stuff in it just to make it unique to this ACR and AKS. And what this image, what this secret is going to allow us to do, it's going to connect, allow AKS and ACR to connect to each other so that AKS can read that image and use that image within the pod. So once the secret's created, we come over here and we're going to be doing a deploy action. And what this is going to do is use our AKS service connection to deploy to AKS. And we're going to be using this deployment.yaml as our manifest. And this, like I said before, this deployment.yaml is for defining what the specification is going to be for our pod and how it is going to be configured. And then we are talking about what the container is, the container registry, the repository within that registry, and then the tag, which is basically going to be the name of the image. So we have the image to make it link up with the pipeline run. The tag is using the build number. So when you go look at ACR, you're going to see a build number, and you'll know that that build is, that number is connected to a Azure pipeline run. So you can go and look at that Azure pipeline run to get specifics. So that is basically the code stuff. Now let's go over to the ACR and the AKS and the pipelines, and I'll walk you through that. And then we'll come back and I'll make a change to the code and we can deploy it. So we already talked about what's in the contents of this, this pipeline. But just to show you, if people are not familiar with how this works, we have service connections. And there are two special service connections that we've created, one for the container registry and one for the AKS cluster. So if we come here and click edit, we can see that we have the details, our subscription ID and the container registry. And that's going to be our service principal for connecting to ACR. This is our Kubernetes one, and this is going to allow us to connect to our Kubernetes. And we can see here we have our subscription, and then we have the cluster within AKS that we're going to be using, and we're going to be deploying this to the default namespace. So it's important to specify the namespace when you do these deployments. So those are the service connections. Now, when we go to our AKS to Azure and look at our AKS and our container registry, we have a registry here, and we can see we have a repository called Lehigh Valley, and this is where we have all of our deployments and our versions. So these are, like I said, artifact versions, and this is the most recent one that we ran today just to test this out. And this is what AKS is going to point to when we tell it to during the deployment. So if we come back to here and then look at our AKS, and we take a look at our workloads, you can see we have this LHV pod, which is our deployment. And then within here, we have a pod. If we drill down even further, we can see this is our container name, which we saw in our, let's see, let me go back to this, to our YAML, deployment.yaml. We can see we have it specified right here in the spec, new repo. So that's what that is for, is setting the name of this container. And we can see that it's pointing to our ACR. I'm just not sure if everybody can see this clearly. With our tag, which is basically our version or our artifact. All right, so any questions about that before we go and show this running in action? I'm not sure if everybody's familiar with Azure pipelines and how that works. So if you have any questions, just feel free to interrupt. So let's go back to our code here. And what we're going to do is make a simple change. So we have this weather forecast controller. And I believe this is what Poornima was pulling up to show when she did the commands. We're going to make a change here and just put Philly in one of them. So I'm going to send this over to our remote. I'll say it's change summary. All right, so that has been done, and we're going to come over here, and we're now going to go look at our pipeline here. And one thing I want to show you is normally when you do this in an enterprise way, like I said, you would have you would be working in a feature branch. You would do a PR to your development branch, and then once it gets to the development, once you merge into the development branch, this pipeline would kick off automatically. So you would have a trigger here set up to automatically kick it off and then deploy it to the dev environment every time you approve a PR and it gets merged into the target branch. So what I'm going to do here, though, is I have trigger none, which means we're not going to automatically trigger it. I'm going to run it manually. So I'm going to come over here and we can see what stages. We're going to do the build stage first and then the dev stage. Okay, so this shouldn't take too long, but as with any build and deploy, we have to wait. Does anyone have any questions while this is running? Sort of fill in the time.
This is just like a microservice, just one piece. You're scratching the surface. Brian, you should tell our experience when you run multiple pipelines together, how long it takes on DevOps.
Well, I mean, it all depends on the code base, right? A .NET application could go pretty fast, but when you have an Angular build, you usually have a lot of things in there that do checks, security scans, and all those type of things. Even just the npm restore takes a long time.
Yep.
So you could have a build that goes on for several minutes, which isn't good for, if you're doing development, you want to see how things are working, you have to wait. But the idea is if you can do your builds in parallel, you have that ability too. If there are no dependencies between them, you could do parallel jobs so that things are running in parallel at the same time rather than in sequence. And that can definitely help out with the speed. All right, so we saw that this thing did a build and a push. And it's 304.3. If we come over here and look at our repository, we see it right here. So it did get deployed, and it's this is our manifest for it. Boy, my mouse doesn't move very well. We just got new computers, and this one doesn't work well with the mouse. So why is this waiting? It's waiting because I have an approval on the environment. So if we come over here and we look at this environment that it's pointing to, we not only can see the deployments that have happened over time, but we can also set this up to have approvals. So you can see I have an approval here that it won't deploy until I actually approve it. We didn't set it up this way, but you can add Kubernetes to this, and you can add virtual machines. So it actually will register the exact Kubernetes that you're using so that you can get into and drill into more of the details of what was going on during that deployment. And as far as the variable group is concerned, this is where you would put your configuration information. And you can see here we have our image pool secret, which is basically just a string, but it has to be all lowercase. It can't have special characters. Like I say, you can't have caps, so it has to be all lowercase, and it will fail if you don't follow that pattern. All right, so let's go over to here again, because it's waiting for us to approve. So I'm going to go and approve this and kick it off. Okay, so it's initializing, downloading the artifacts, which includes that YAML file, deployment.yaml, did the image secret, and now it's doing the deployment to Kubernetes. And that was pretty fast. This is generally fast. Of course, it could be longer if you have a much bigger deployment.yaml file that does a lot of different configurations. Ours is incredibly simple for just the demo purposes. So it is quite fast. So we come over here, you see that we have this image that Kubernetes should now be pointing to, 3.4.3. So if we come over to Kubernetes and look at that pod, we should be able to see that that's exactly what it's using. So it's using 304.3. So what the key thing here is to remember is you could do the deployment to the container, to the container registry, but a running AKS cluster and pod will point to the previous one until you tell it to use the new one. So that gives us the ability to be able to build once and then deploy that to different environments when you're ready in sequence. So that's the overall workflow of the developer view and the pipeline view. So it's pretty simple, but like I said, it can get as complicated as you need to based on your scenarios. So That's it for the demo for right now. Now, Poornima, do you want to go and show
Yeah.
that?
Yeah,
So
I
I'll
can
stop.
share.
I'll stop sharing.
So I think when Brian was running his deployment, I kind of went. Can you see my screen, Brian?
Yeah.
Okay. So before we went to the demo, we went inside the pod, which is this one, which means the container. It has everything it needs to run this web app. It's a C Sharp ASP.NET web service, so it needs an app service to run. We did not do anything. We just deployed an image. That's all. And it's self-sufficient. It's running, right? Which you were able to see when you did a curl inside the app. Now, I just did a kubectl get pods a while ago when Brian was creating a new container. You can see the old container was running, and then the C8 NML at the top is getting created in the process. So when you create a new container, the old one goes away. And I have a question for this team. Who handles the scheduling and monitoring of these containers and deletes one when something else opens up? Just take a guess. I'll give you three options: Docker, Kubernetes, Azure, or AKS.
What was the question again? Maybe I didn't hear it.
Yeah. So when you created a new container through the pipeline, you see how it says container creating? And it took like 2 seconds to create the container, but then I just ran the command now. It created the new container, which is underscore C8NML, but then it overrode the previous container, which was running within the same pod because we are creating a new image. We just published a new artifact. So the cleaning up of existing old containers, it goes away without us having to take care of cleaning it up, right? So my question was why, who handles the scaling and deployment and scheduling of these containers? To make sure when one gets created, the other one is not running, or if we need multiple, we just scale them like hundreds or thousands, right? So the answer is actually Kubernetes. The Kubernetes is the orchestration engine, which takes care of all the mess that you don't want to handle. So this was developed by Google. Azure actually brought it inside using Azure Kubernetes services to make the interaction much more easier. And that's why the AKS deployment that Brian showed makes sense, because now when you're deploying microservices in huge amounts, you don't have to worry about deployment, scaling, load balancing, and all that stuff. Now let me go inside. So the last time we had an older container, like older pod, which Brian rewrote by doing a change. So I have to copy the new one that's running, and it's running for 2 minutes now. And I just exec, do a Linux command to go into my container. These are all Linux containers. And do a curl again. And I need to do the HTTP because the container is running, which means it's listening. It's just an API. And you can see that it changed it to fully freezing. It was freezing before. And this is such a powerful thing for developers, especially when you're doing that deployments, which have to be in minutes and you can have zero downtime. What we have right now is very impressive. So that's why microservices flow really well into DevOps. So I think that brings to the end of a presentation. I just had to ask a question to make sure we all understand Kubernetes. What I showed initially was a container deployment in my local. But if you are going to push the container and ship multiple containers like that, you need an orchestrated engine like Kubernetes. So it helps you with scaling and load balancing, resource allocating. For example, some of your services are not CPU intensive. So how do you make sure the VM or the bare metal underneath is catering to all these containers without having to pay for more? And all that thing, Kubernetes abstracts it. So all you need to do is learn about it and do a deployment file that Brian showed. I think we're almost out of time. We'll stop for questions, but you guys have our email, so if you need to reach out to us, feel free to.
We are actually out of time because we're supposed to finish at 5 of.
Okay. All right. Have a great weekend, everybody. Happy Friday.
Thank you.
Thank you.
Thank you. Bye.